This is 7.4, which is parallel lines and proportional parts. Okay, again, your postulate sheet's going to be useful here if you have it around, because it covers some of those theorems that we're going to talk about, or all the theorems we're going to talk about. The first one is called the triangle proportionality theorem, 7.4 on your sheet. Okay. It says if you have a line that's parallel to one side of a triangle, and it intersects the other two sides of the triangle, like this here, okay, then it separates it into into segments of proportional lengths. Meaning that if I made the proportion of BA over CB, that's equal to DE over CD. That if this line is parallel to one side of the triangle and it intersects the opposite two sides, you can write a proportion of this side to this side equal to this piece over this piece. Or you could go the other way again. You could say the blue over the yellow is equal to the blue over the yellow. Doesn't matter which one is the numerator, as long as your cross products are the same. Okay. This is called the triangle proportionality theorem. It separates it into proportional parts. Separates a triangle into proportional parts. Okay. If these lines are parallel. On your postulate sheet 7.4. So that first figure you have there, okay, tells you in this triangle these two lines are parallel. That's what our arrows mean, right? SV is 3, VR is 8, UT is 12. Find out what X is. So you can write your proportion here of one side over the other is equal to one piece over the other. In this case, if I started with SV, this side, SV over VR, so that's 3 over 8, or you could do 8 over 3, is equal to, since I started with this piece, I'm going to start with this piece, X over 12. Again, if you did it the other way, if you did 8 over 3, you would have 12 over X. Those are both the same cross product. Good. So solve this cross product. You get 8x equals 36. Divide both sides by 8. Get 4.5. Okay. So it just says solve for x. X is 4.5. Find out what SU is. Well, SU is just x, so it's 4.5. That's applying the that mid-segment theorem. The triangle proportionality theorem. Applying the triangle proportionality theorem. Two parallel lines separates it into proportional parts. So try this one. It's the same theorem you're applying here. Two parallel lines. Separates this into proportional parts. See if you get an answer that matches one of these solutions. So again, doesn't matter which piece you start with. If you start with this piece, you would do 4 over 10.5 is equal to 6 over x.
Why would it be 14.5?
Because it's just the proportional parts. We're just talking about this and this. That's what the theorem says. And this to this. Okay. Those are the proportional parts. So when, again, if you had 10.5 over 4, that's fine. You would have x over 6. Cross multiply. Oops. You get 4x is equal to 4. And I think you get d 15.75. So x is 15 3/4. Questions there on that theorem? Pretty straightforward. If the two parallel lines, you can write your two proportions from those. All right, the next one is just the converse of that theorem. Okay, it's just flipping the if and the then. All right? So if it separates it into proportional parts, if you can write BA over CB is equal to DE over CD, then you can show those lines are parallel. Just the converse of that theorem. If they're proportional, then those lines are parallel. The one we said before said if they're parallel, then those parts are proportional. Okay. So for example here, if you want to determine is GH and FE parallel, are these two lines parallel? Okay. We're going to check if these proportions, if this is a two equal ratio. So what I'm given is that DH is 18 and HE is 36. And then all I know about the other side is this piece is half of the whole thing, right? And my question is, are these two parallel? All I know is this green piece here is half of the whole thing. So I have to check, are these two things the same ratio? Are they proportional? So even though I don't know this side, I know this is half of the whole thing. Is 18, okay, half of this piece? Sorry, this is half of, I have that line wrong.
Why is the middle one?
Half of that. What?
Oh, is that a question mark?
Yeah, there's a question mark, sorry.
Okay.
Okay. So 18 is half of 36, right? And I know DG, whatever it is half of GF, whatever it is. I don't have to know what it is because I know 18 over 36 is half, and DG is half of GF. So they're both, okay, are half there. So they're proportional, meaning that these are parallel by the converse. GH is parallel to FE by the converse of triangle proportionality theorem. Okay. Again, on your postulate sheet, just the converse of what we were saying before. Before, if they're parallel, these are proportional. Now, if these are proportional, then they're parallel. Okay, I think it's 7.5 on your postulate sheet. So here I want to know, is WX parallel to AY, knowing this information? So try that a second, and then we'll check our answer together. So here when you want to check if these are the same proportion, you either do 15 over 25, is that equal to 18 over 32, or vice versa. So I'm checking, are these things the same? Okay. If they're proportional, then those lines are parallel. If they're not, then they're not parallel, or at least I can't prove it that way. Okay. Or they wouldn't be. One way to do it is just get your cross products, multiply 15 and 32. Is that the same thing as 18 times 25? The other way to do it is you can just simplify both those fractions and see if they're the same. 15 over 25, both those are divisible by 5. Both these are divisible by 2. Neither of those can go any further. I know 3/5 is not the same as 9/16. So these are not proportional. So this would be no, these are not parallel. WX is not parallel to AY because it doesn't pass the theorem.
When is it cannot be determined?
Back page there. Next is the triangle mid-segment theorem, 7.6 on your sheet. Okay? Remember, like a mid-segment of a trapezoid goes from the midpoints of both legs? The mid-segment of a triangle goes from the midpoint of two of the sides. So the theorem says a mid-segment of a triangle is parallel to one side of the triangle. Okay. So in this case, this would be parallel to this. Okay. And its length, BD, is 1/2 of this side, AE. So if this was 4, this would be 8. If this was 5, this would be 10. If this was 20, this would be 40. Okay. So that's if it's the mid-segment. So to be the mid-segment, it has to cut this side in half, and it has to cut this side in half. Say it again. Right. There has to be a midpoint here, then we call that piece the mid-segment. If it's the mid-segment, it's parallel to this side, and it's half of this side. Okay. If that's the mid-segment. So that's 7.6, the triangle mid-segment theorem. The last two corollaries here that are on your postulate sheet, okay, says if you have 3 parallel lines and they intersect 2 transversals, so here's my 3 parallel lines. Remember, a transversal is just a line that cuts 2 or more other lines. So 3 parallel lines here cut these 2 lines, these 2 transversals. Then they cut them proportionally, meaning that AB over BC, so this piece over this piece is equal to this piece over this one. Okay? If you have 3 parallel lines and 2 lines that cut them, it cuts them proportionally. Green over red is equal to green over red. AB over BC, DE over EF. Okay? And the last one, if 3 or more parallel lines cut off congruent segments of one transversal, then they cut off congruent segments on another one. We're going to come to a problem just like that in just a second. Okay. So those are the last theorems. So let's see how we apply them here. Your first one there, it's got 3 streets. Okay. It tells you these 3 streets are parallel, and the figure shows the distances in city blocks that the streets are apart. So from here to here is 16 or 26, here to here is 13, here to here is 16, here to here is X. The question is, how far is it on this road? Okay. It told you in the problem that you have these 3 lines are parallel. And the theorem says if you have 3 parallel lines and they're cut by 2 other lines, here and here, then it cuts them into proportional parts. Okay. So if I started with this piece, 26 over 13 is equal to X over 16. Or if you did it the other way, would be that. Proportional parts. This over this is equal to this over this, if these lines are parallel. Now, you could go ahead and cross multiply and solve this, but you could also get it just by looking at it here. You know 26 is double 13, right? So if they're proportional, this piece has got to be 32 because you just double 16, right? To get from here to here with times 2, so to get from here to here times 2. That's the same thing you get when you cross multiply. So I would get X is 32. Again, if you want to cross multiply to get that, that is also correct. Yes. This one yourself. Then I want to know how far from this main to broad you know that you have 3 parallel lines. See if you get one of these answers. So separates it in proportional parts. You can start with either one of these pieces. If I start with the larger one, 24 over 8 is going to be equal to 15 over X. This one to this one is equal to this one over this one. Okay. Or you could have them flipped. Again, you can cross multiply here to get your answer, but if you look, 24 divided by 8 is 3. So to get from 8 to 24, you multiply by 3. You'd have to do the same thing over here for them to be proportional. So that means X would have to be 5, because 5 times 3 is 15. Right? So you would get X is 5. Again, to get from here to here, multiply by 3, means to get from here to here, you'd have to multiply by 3. That's what it means to be proportional. Questions there? Feel okay with that? All right, last 2 here. This one is looking at the that corollary 7.2. Says if you have 3 or more parallel lines and they cut off congruent segments on one transversal, then they cut off congruent segments of the other transversal. Does that make sense?
This is 7.2.
Corollary 7.2, yeah. So in this figure, I just want to know what are X and Y. These 3 parallel lines cut off congruent segments on this transversal. So by that theorem, they must cut off congruent segments on the other transversal. So those 2 must be congruent. That's by corollary 7.2. Cut off congruent segments on one transversal, must cut off congruent segments on the other. So to solve for X and Y, well, I know from here to solve for X, this chunk is equal to that chunk, so I can just set those 2 things equal to each other. 2x plus 2 is equal to 3x minus 4. If I subtract 2x from both sides, I get that. If I add 4 to both sides, I get x is 6. Right. And then by that theorem, I know these 2 pieces are congruent, so I can set them equal to each other. I know 8/3 y plus 7 is equal to 5y. So you have to deal with some fractions here. Let's just do that together to make sure we're on the same page. I need to get my y's together on the same side of the equal sign. So let's move this 8/3 y to the other side. We do that by subtracting 8/3 y from both sides. Right? So I would get like this, 5y minus 8/3 y. If I move that positive 8/3 y over, I just subtract it to both sides. These are like terms, so I can subtract them, but I need to subtract fractions, which means what has to be true about the denominator. They have to be the same, right? So my denominators here are 1 and 3. That means the common denominator is 3. Don't have to change this one, but I have to multiply this one by 3 over 3. So I would get 15/3 y minus 8/3 y. And when you take 15 minus 8, you get 7/3 y. So all I have to do at this point is get y by itself. That's like 7/3 times y. So to undo that, I would divide both sides by 7/3. But dividing by 7/3, when you divide by a fraction, that's the same thing as doing what? Multiplying by it flipped. Multiplying by the reciprocal. Right? Make sure that is put away so I don't have to take it. So I multiply both sides by 3 over 7. Because this is going to give me 21 over 21, which is 1y. Which means I have to multiply this side by 3 over 7. So I put that 7 over 1, just so it's easier to multiply the fractions. So I would get 21 over 7 there, and 21 over 7 is 3. So I would get y is 3.
Can you just simplify this?
Since these two sides are congruent, Corollary 7.2 says if 3 parallel lines cut off congruent segments of one transversal, they cut off congruent segments of the other transversal.
But how do we know that those two are equal to?
So since those two sides are congruent, those two must be congruent, and that's going to get us to solve for A and B. A would look like 4a minus 5 is equal to 3a plus 6. Subtract 3a from both sides. Add 5 to both sides. A is 11. I would do the same thing with B. Subtract 5/3 b from both sides. So I would get 3b minus 5/3 b equals 2. So again, common denominator here is going to be 3, so I have to multiply this one by 3 over 3, which is going to give me 9 over 3.
What? Wait, 1 second. Okay,
Yeah, no calculator, so you got to get common denominators. 3 times 3 is 9/3. 9 minus 5 is 4/3 b. Okay. Again, just like before, you want to divide both sides by 4/3, dividing by fractions, the same thing as multiplying by it flipped or multiplying by the reciprocal. So I'll multiply both sides by 3 over 4, 3 over 4. That's going to become 12 over 12b, which just leaves me with 1b, which is what I want. This will become 6 over 4, which simplifies to 3/2, which is 1 1/2. So b would be 3 over 2.